It's great to be here with you guys tonight. Is this too loud? Are you guys being blown away here? A little bit too loud? I'm seeing heads nodding. Can we adjust the sound back here without screwing it up? I don't know. Or I could move the microphone down maybe. How's that? I've got so many microphones on me. I hope I'm moving the right one. Is that any better? Okay, all right. Okay, if you're getting blown away, just raise your hand or shout out and I'll tone it down. It's great to be here with you guys tonight. I'm from Southern California originally and also a UC San Diego alum, so it's always nice to be back down here, and it's a real pleasure to speak here at UCI. I used to work right down the street when Flora Daniel was based right off of the MacArthur exit. For a whole summer I had an internship, and so it's a great area. I noticed and thank you Daryl for the very kind introduction, I noticed on on your flyer about the Do the Right Thing week, and there was something about how you have the right to disagree. And I like that because I just want you guys to know tonight, I understand that this is a very controversial topic and people have different views and different ideas and sometimes very strong feelings. And as we go into this tonight, I want you guys to know that it is okay to disagree. You don't have to agree with everything I'm saying. This is one of those many issues where reasonable people can and do disagree. So I just want to say that straight off, that if wherever you're coming from, would love to hear from you, and I hope we can have a very friendly and constructive Q&A session afterwards, including disagreeing questions would be great. So I think it's good that you guys are actually promoting that kind of a forum. A little bit of background: when I was a student actually at UC San Diego, I started a club called the Idea Club. We have Ryan Huxley here from the Idea Center. Idea is short for Intelligent Design and Evolution Awareness, and the purpose of the Idea Club was basically to allow students to have the opportunity to debate and dialogue over the topic of origins, looking at the scientific question of intelligent design and Darwinian evolution, to ask those kinds of questions and have that discussion in a way where most of the classes were not letting them have that discussion. And my experience when I was in college, actually, I went to public schools from kindergarten through my master's degree. And my experience all the way through, almost 100% of the time, was that my classes, by and large, did not allow us to have a discussion and a debate over origins. The pro-evolutionary view was the only view that was taught. Any other viewpoints were basically not discussed. And if they were discussed, it was in a very caricatured kind of way, where basically they were laughed at. There was not a serious conversation going on over origins. I firmly believe that there is a serious scientific dialogue to be had on this issue, and I think it's important to have that. So I really appreciate what you guys are doing here at Ratio Christi, inviting folks to have a serious, friendly, constructive dialogue on this issue, because unfortunately, for most of you guys who are students here, it's probably not happening in your classes. You're either not having the dialogue at all. Basically, any of the science that challenges Darwinian evolution is basically being censored from you guys. Any of the viewpoints that support intelligent design, they're basically being censored from you guys. And if they are mentioned, they're mentioned in a caricature, in a way that really does not accurately represent where those viewpoints are coming from. So part of what I hope to accomplish today is to expose you guys to a pro-intelligent design view in a way that isn't a caricature, that actually accurately tells you guys what ideas, so at least then you can make up your own mind. And so just one last point before we get into this. There's a lot of confusion over, maybe what folks in the ID movement think should be taught on this issue. We are not trying to say that evolution should not be taught. I absolutely want evolution taught in schools, and I think that the pro-evolution view must be taught in schools. The problem is that that's not the only view that should be taught. And in most schools today, the only viewpoint that's taught is the pro-evolutionary view. Pro-Darwin only is how I would put it. And there are other legitimate, credible scientific views out there that deserve to be heard. So I think what students should have is full access to all the scientific information on this issue, so you can make up your own minds. Whatever opinion you come to, whatever decision that you make of what you're going to believe on these very important questions of where we came from, just make sure you have access to all that information. You've studied both sides of the issue or all sides of the issue, and you've formed your own opinions. If you guys are here tonight, you're already well on your way to doing that, so I'm not worried about it. But the problem is that there's a lot of folks out there who really have not heard from other views other than the pro-Darwinian view that they're being taught in their class. So they don't have access to all the information. So they're like a jury that's trying to render a verdict in a trial, but only one side of the case has been given. They haven't heard the other side of the case. So I hope that you guys can hear maybe another side tonight that you haven't heard. So a quick outline of where we're going. We're first going to just talk briefly about what is intelligent design. How do we define intelligent design? There's a lot of misinformation and misdefinitions out there, so I'm going to find ID for you guys. Next, we're going to talk about, is intelligent design testable? Can we actually test for intelligent design? Does it make testable predictions? Then we'll talk about, does ID use the scientific method? Oh, that's great. Is that better? Okay, all right, good, good. I'm not all washed out now. We'll look at the question, is ID science? And I think it's a very important and a legitimate question to ask. If you're a skeptic of ID, great. A very important question to ask is ID science? And I think that because ID uses the scientific method to make its claims, there's a very strong argument that can be made that ID is science. And finally, we're going to look at 5 testable predictions of ID. This section is going to take up most of our time tonight, and we're going to look at 5 different fields and how ID makes testable predictions within each of those fields, and we'll see that, in my opinion at least, the data and the evidence confirms those testable predictions of ID. So, first off, let's define intelligent design. What is intelligent design? I like to start off my talks with a little survey. What do you think intelligent design is? And I want you guys to give me an honest answer of what you think ID is. Don't tell me what you think I want to hear. You guys are probably smart enough to figure that out. Give me an honest answer. If you were to define ID before you came in today, how do you think it would be defined? So would you say it's A, that life is so complex that it couldn't have evolved, therefore it was designed by a supernatural being? Or would you say that it's B, many features of nature are best explained by an intelligent cause because in our experience, intelligence is the cause of their informational properties? So no shame whatever your answer is. Who would say the answer is A? Okay, fair enough. Wow. I was expecting more A's. Okay, who would say the answer is B? Okay, wow. All right. Normally it's about 50-50, and that's when I'm speaking to, whether I'm speaking to friendly audiences or skeptical audiences. I have no idea what this audience is. So if you said that the answer is A, you're wrong, but don't feel bad, because all this means is that you read newspapers. Because this is the definition of ID that gets sort of mindlessly recycled in newspaper articles after newspaper articles after newspaper articles. If there are reporters in the room, please don't be offended. I'm not saying that you're going to make this mistake, but I've seen a lot of reporters make this mistake. They literally will copy and paste from other news stories with the wrong definition of intelligent design. So let's just talk briefly. Why is definition A the wrong definition? Well, there are 2 main things about definition A that are wrong. The first one is that it frames intelligent design as strictly a negative argument against evolution. It says life is so complex that it couldn't have evolved, therefore it was designed. So why is that wrong? Well, people will say, well, aren't you going to critique Darwinian evolution? Don't ID proponents make a lot of criticisms of evolutionary biology? And the answer to that is yes. But that in and of itself is not the entire case for intelligent design. Everybody knows that evidence against one theory is not in and of itself therefore evidence for another theory. You have to make a positive argument for the hypothesis that you're putting forth. And ID is based upon that kind of a positive argument that's not simply based upon critiquing or negating evolutionary theory. So the first problem is that it frames ideas as strictly a negative argument against evolution when there's also a very important positive argument for design. We're going to talk about that quite a bit tonight, and I'll try to emphasize to you guys how that positive argument works. The other problem with definition A is that it introduces ID and it defines ID as explicitly referring to a supernatural being. That is not how ID works. ID, as it's been defined by its proponents, does not get into religious questions about the nature or the identity of the designer. ID limits its claims to what we can learn through a scientific investigation, and as a result, ID only infers an intelligent cause and doesn't try to get into questions like whether or not the designer is natural or supernatural or so forth. Now, the first question I get back a lot of times when I say this is, well, Casey, I Googled your name. And after I read all the terrible things that all the, your angry critics on the internet are saying about you, I find out that you are a Christian. You believe in God. You believe the designer is a supernatural being. So how can you say that ID does not claim that the designer is a supernatural divine being? And my answer to that is, you've got me. I'm a Christian. I don't try to hide that. As a matter of fact, I'm very open about the fact that I'm a Christian, whether I'm speaking to secular audiences or religious audiences or probably mixed audiences like this. I think it's very important to be just upfront about where you're coming from. However, my belief that the God of the Bible is a designer is my own personal religious belief that I hold for other reasons, and it's not a direct conclusion of intelligent design. Intelligent design tries to respect the limits of science. And so it doesn't go beyond what the scientific data can tell you. So let me just give you a quick example, and this will make more sense as we get into the talk, but let's just say hypothetically that the bacterial flagellum, that famous molecular machine that ID proponents love to talk about, let's say the bacterial flagellum testifies to having been designed by an intelligence. Well, the bacterial flagellum is just a little micromolecular machine. It doesn't say on it, made by Yahweh, or made by Allah, or made by Buddha, or made by Yoda, or made by whoever you might think the designer is. It's just a complex molecular machine. So we can infer design. We can infer that an intelligent cause was necessary to generate that natural structure. But if we go further and then say, and the designer is, fill in the blank, you're going beyond what a strictly scientific investigation can tell you. So these are principled reasons for why ID does not identify the designer. These are not really merely rhetorical reasons that are trying to, be coy or something like that. You can look at just about everybody who's a main leader in the ID movement, and they've been very open about what they believe about God and religion and who they believe the designer is, and they will make it very clear as well. These are their personal religious beliefs. They're not the direct conclusions of intelligent design. All ID infers is an intelligent cause. And because of this, you actually have folks in the ID movement who are not even religious. There are agnostics and even some atheists who are members of the ID movement. We can get into some of the names of some of those folks later on if you want. But it's interesting because it's clear that the ID movement is not unified around some kind of religious view because it includes atheists and agnostics. What unifies the ID viewpoint is a conviction that scientific evidence requires and points to an intelligent cause as the best explanation for what we see in nature, or many aspects of what we see in nature. So that's just a couple things about what's wrong with definition A. So definition B is the right definition. Many features of nature are best explained by an intelligent cause because in our experience, intelligence is the cause of their informational properties. We're going to flesh this definition out in a lot more detail tonight, but for now, just note that ID is based upon finding in nature the type of information which in our experience comes from intelligence. We have experience with the natural world around us. We understand what intelligent agents can and cannot do. And by studying intelligent agents and by understanding the effects that they generate when they make things, when they design structures, we can learn to recognize the telltale signs of design in nature, and we can recognize those telltale signs by looking for information. What is the kind of information which in our experience comes from intelligence? This is a positive argument, again, based upon finding in nature what in our experience comes from intelligence. So ID reasoning is already being used in science. Let's say hypothetically that you go to this Planet of the Apes and you find these weird monolithic structures that are growing out of the ground. You want to ask yourself, how did they get there? Are they just natural geological structures that grow out of the ground? Do these apes build them by instinct? Were they designed by some kind of a superior intelligent alien race? ID is in the business of discriminating between naturally caused objects on the one hand and intelligently caused objects on the other. So if you're looking at a structure and you're trying to ask the question, was this designed or did it arise through natural causes? You're trying to make a design inference. You're using ID reasoning. And there are a number of different fields that already use that kind of reasoning. For example, archaeology, if any of you guys have been hiking and you found a rock that you think might be an arrowhead and you're trying to determine, did this rock acquire its shape through just normal natural processes like water action and tumbling down through a stream, or was it carved into that shape for a purpose? You're trying to make a design inference. And archaeologists regularly use this kind of reasoning to try to make a design inference and determine whether or not a rock was carved into a shape for a purpose. Another field that uses ID reasoning is forensic science. Our legal system is in the business of trying to discriminate between naturally caused deaths on the one hand and intelligently caused deaths on the other, otherwise known as murder, right? So these are actually very important questions that our legal system has to answer. Our legal system is set up to make or reject design inferences. All the time it happens in courts of law, every single day. And so forensic science is a big part of helping people to make design inferences to determine whether or not a crime was committed as an act by an intelligent being or if the person died of natural causes. So what ID proponents are saying is, if we can detect design in these other fields, and we can recognize the telltale effects of intelligence in these other fields, why can't we also detect design in biology, where we've discovered that all of life is fundamentally based upon a language-based code in our DNA. And in our experience, language-based code comes from only one known source, and that's intelligence. So this is sort of what the kind of questions that ID is asking. Another field that uses ID reasoning is the search for extraterrestrial intelligence, otherwise known as SETI. If you guys have seen the movie Contact, you remember that SETI actually used to be a government-funded project. They have an array of radio telescopes that are scanning the skies for radio signals that they hope were sent by an extraterrestrial alien civilization trying to get our attention, right? So what is SETI doing? They're trying to discriminate between naturally caused radio signals on the one hand and intelligently caused radio signals on the other. They're trying to make a design inference. Now, they haven't found any extraterrestrial signals yet, although I think I know what they would be saying if they did, but I think just the very fact that they are trying to do this is very significant. They're trying to make a design inference. And even though I think the folks at SETI probably wouldn't like the ID movement very much, many of them are what you might call materialist atheist types, the very fact that they are trying to perform this project is significant because it shows that they are using ID reasoning within science to detect design in an extraterrestrial radio signal. So is ID testable? This is one of those big questions that gets asked a lot. Let's talk a little bit about how ID works and how we make a design inference. Well, if you guys have taken geology courses, you probably learned about a famous book called Principles of Geology by Charles Lyell. He was the father of modern geology. And in this book, he came up with this concept of uniformitarianism. And he had this phrase called, the present is the key to the past. Well, what does that mean? Uniformitarianism says that we can look at causes that are in effect in the world around us today and understand what they can do. And then we can apply those causes to explain events that took place long ago in the deep past. So basically, we get to make the assumption that causes that we can understand by studying the world in the present day right now, we can use them to help us understand what happened in the past. So this led to Lyell's famous dictum, the present is a key to the past. And he said in his book, it's an attempt to explain the former changes of the Earth's surface by reference to causes now in operation, or again, the present is the key to the past. Well, this is exactly how intelligent design theory works. ID looks at the world around us and studies intelligent agents to understand what they can and cannot do. What do we find in experience when an intelligent agent has acted? What are the telltale signs that an intelligent agency has been at work? And then when we find those telltale signs in the historical record, we can infer that an intelligent agent was at work using this very concept that the present is the key to the past. So what do I mean that we can study intelligent agents and figure out what they can do? Well, this is what I'm talking about. This is a quote from a famous information theorist named Henry Quaisler, who I think committed suicide in the 1960s. And he said, the creation of new information is habitually associated with conscious activity. In our experience, new information comes from intelligence. Now, of course, there are many different definitions of information. So what kind of information are we talking about that in our experience comes from intelligence? Well, Stephen Meyer, who works at Discovery Institute, he has a great explanation of the kind of information which in our experience comes from intelligence. He says, our experience-based knowledge of information flow confirms that systems with large amounts of specified complexity, especially codes and languages, invariably originate from an intelligent source, from a mind or a personal agent. So this, I think, is very significant. He's saying that in our experience, when we see codes or languages, that these come from an intelligent source, from a mind or a personal agent. Now, he kind of used those as an example of this jargony term here, specified complexity. I'm going to flesh that out for you guys in just a couple minutes. But for now, just understand that in our experience, whenever we see codes and languages, they come from intelligence. Whenever we know their source, it traces back to a mind or a personal agent. Isn't that interesting? Isn't that interesting? Do we find codes and languages in life? We'll talk about that some more. So what is this jargony term, specified complexity? Well, information is complex if it is unlikely. So for example, the zeros and ones, we'll call this little bug, a little microscopic organism under a microscope. We'll say that we're looking at it under the microscope, we find that it contains these series of zeros and ones. Now the odds of these zeros and ones being in exactly this order is very unlikely. So we would call this a complex sequence of binary digits. Now, is unlikelihood alone enough to infer design? No, it's not. Let me give you guys a quick illustration that shows what I'm talking about. I could deal you guys each out a 5-card hand of poker, and you would each get a very unlikely hand. Now, even if you got a really good hand of cards, you're not going to infer design. You're just going to infer, okay, I got lucky, I got a good hand of cards. So unlikely things happen all the time, and that does not necessarily lead us to infer design. But let's say that I were to deal you out, and each of you got a royal flush. And then I did this again, and everyone in the room got a royal flush. And then we did this 100 times, and every single time, every one of you got a royal flush. Well, now you're going to begin to suspect what? That the deck is stacked. It wasn't just the random shuffling of cards that generated this outcome. It was predetermined by an intelligent agent to yield a particular outcome. So you're going to infer design because you've seen that yes, something unlikely happened, but it also matched a specific pattern. So just because something unlikely happens is not enough to infer design. You need to have something that's both unlikely and matches an independent pattern. So it turns out actually that these zeros and ones, they are not just a random sequence of zeros and ones. They're actually, for the computer nerds in here, it's actually binary code for the ASCII characters that spell out this sentence. Biology is the study of complicated things that give the appearance of having been designed for a purpose, which of course is a quote from our friend Richard Dawkins, who actually probably wouldn't call himself our friend because he does not like intelligent design. Dr. Dawkins, he's a very smart guy. He would say that natural selection is what did the designing, and that there is no real design in nature, it's only apparent design. So I would say that if something looks designed, maybe we can take seriously the possibility that it actually was designed. Dawkins thinks it was designed by natural selection. I think it was designed by design. And the reason it looks designed is because it actually was designed. So this is a good example of an unlikely sequence of numbers that actually matches an independent pattern, namely, again, the binary code for the ASCII characters that generate this, this sentence. So here we can detect design, and we can see that it's both specified and complex. Let's look at another illustration of what it means to say something is specified and complex. We're going to use this goofy illustration from Johan. Johan is on a tour of mountains in the United States. He's from Eastern Europe, and he's looking at different mountains in our country. And he goes, of course, not right now because all the national parks are closed. But let's say he comes back, you know, hopefully in a couple weeks when all the folks in DC have gotten over their issues, and they work it out, and he goes to some national parks. All right, so he first comes across this mountain, and he says, okay, this mountain has a very unlikely shape. The odds of this mountain having a ridge right here, and a gully right here, and another ridge here, and another ridge here, and every rock face on this mountain having the exact shape that it is very likely. So he could say, yes, this mountain is complex, but he's not going to infer design. This mountain does not match any kind of an independent pattern, so he's going to say, okay, you know what? This looks like a normally weathered mountain. I can explain it using the normal processes of wind and rain and heating and cooling and freezing and thawing. He can explain the shape of this mountain without inferring design. You guys already knew where I was going next. So then he comes to this mountain, right? And he says, okay, well, I come to this mountain, and this mountain is complex, yet it also matches a known pattern. So it's both a specific pattern plus complexity. That is how we infer design. So it's complex because it has a very unlikely shape, and it's specified because it has a pattern that matches the faces of 4 famous presidents. So we can here infer design. We have a specific pattern plus complexity, and that's what we need. We need both of those in order to detect design. Okay, so the basic logic here, just boiling it down to its very essence. A pro-ID scientist goes out and studies the world around them and figures out that mind is the cause of certain types of information. Then she goes out and studies natural objects and determines that they contain the same kind of information, which in her experience comes from mind. And as a result, she infers that a mind was at work. So this is the very essence of the logic for intelligent design. Okay, so again, the question that people love to ask, and I think it's a fair question, is ID science? How can we know whether ID is science? Well, for the philosophers in the room, I know that folks disagree over how to define science, but I like to say that if something uses the scientific method to make its claims, there's a pretty good chance that it falls on the science side of that line between science and non-science. And it turns out that ID does use the scientific method to make its claims. Now, the scientific method is often described as a 4-step process of observation, hypothesis, experiment, and conclusion. So how does ID use this method to make its claims? Well, first off, ID begins with the observation that intelligent agents produce high levels of complex and specified information. We already talked about that a little bit. So design theorists then make a hypothesis that if a natural structure, such as X here was designed, then it will contain high levels of CSI. So we're making a testable prediction that ID says we will expect to find high levels of CSI in nature. ID theorists can then perform experimental tests on natural objects to determine if they contain high CSI. Examples include genetic knockout tests, mutational sensitivity tests, and theoretical computer simulations. I'll give you guys a couple of really brief examples of how ID researchers are actually using each of these kinds of experimental tests right now to test for intelligent design. So one easily testable form of CSI is irreducible complexity, which exists when we have a structure that requires a certain core number of parts in order to function. And when you remove any one of those parts, the structure stops functioning. So we can actually experimentally test for irreducible complexity by reverse engineering biological structures through genetic knockout experiments to determine if they require all their parts to function. And actually, Scott Minnick, who's a pro-ID microbiologist at the University of Idaho, he's performed genetic knockout experiments on the bacterial flagellum, and he's found that it is indeed irreducibly complex with respect to its approximately 35 genes and also lacking in evolutionary precursors. So he's made a good case, I think, experimentally, through knockout experiments, the flagellum is irreducibly complex. Another way we can define high CSI is through mutational sensitivity tests. And this is used to determine how finely tuned amino acid sequences in proteins have to be in order for functional proteins to operate properly. So what am I talking about here? Well, if you guys, many of you, I'm sure some of you guys are probably biology majors, and if you're not, here's just a quick review. Proteins are basically long chains of amino acids that are folded up into a very precise shape to perform some kind of a complex function in a cell. And it's well known that the amino acid sequence of proteins, at least many of the amino acids, have to be just right in order for them to function properly. Some of them can tolerate mutations, but many amino acid sequences have to be just right in order for a protein to function properly. And Douglas Axe, who's a protein scientist at Biologic Institute, which is a lab that investigates intelligent design, he's performed mutational sensitivity tests on beta-lactamase enzymes in E. coli and found that functional protein folds may be as rare as 1 in 10 to the 77th amino acid sequences. So this is actually a direct measure of CSI. So just to give you guys a little diagram to show what I'm talking about here, if you think of sequence space, you're plotting here sequence space, so your amino acid sequence versus enzyme activity, which is basically a measure of functionality. What he found is that as you go through sequence space, you really get no or negligible function until you get to a very particular point, and then bam, a very precise sequence gives you very high enzyme activity. And this research was actually published in Journal of Molecular Biology, and this is where he found, again, that functional amino acid sequences that yield functional proteins are as rare as 1 in 10 to the 77th sequences. And we can convert that to a direct measure of CSI. Comes out to about, I believe, 255 bits. So another way to measure CSI is through theoretical calculations and computer simulations to determine how much CSI can be produced via blind and unguided Darwinian processes. This is an important question that ID proponents are asking. What is sort of the edge of what evolution can do? How much can evolution produce? And there have been a number of ID studies that have looked at this, but an interesting one was published in the journal Protein Science a few years ago by pro-ID biochemist Michael Behe and pro-ID physicist David Snoke. They performed computer simulations and theoretical calculations showing that the Darwinian evolution of a functional bond between two proteins would be highly unlikely to occur in a population of multicellular organisms. So what they basically did is they ran the numbers and they found that if more than 2 simultaneous mutations are necessary to produce a functional protein-protein interaction, it is unlikely to ever evolve in multicellular organisms. And this is just basically a function of population genetics. You plug in realistic population sizes, you plug in realistic generation times, and how long it takes for these organisms to reproduce, how quickly you can generate mutations. And basically, it's very unlikely to generate even very modestly complex features that require more than 2 mutations before they provide some kind of a selective advantage. So I think this is very interesting results because it suggests that many complex biological features might be beyond the edge of what Darwinian evolution, mutation selection, can accomplish. What was interesting is that a couple years after this paper was published, some of Behe and Snoke's critics tried to refute them in the journal Genetics. And they found, ironically, is that to obtain only 2 simultaneous mutations via Darwinian evolution for humans with a much smaller effective population size, this type of change would take over 100 million years. And the critics admitted this is unlikely, very unlikely to occur on a reasonable timescale, especially when you consider that our supposed most recent common ancestor with chimps lived about 5 to 6 million years ago. So again, I'm talking about simultaneous mutations. We're talking about a feature that does not give you any selective advantage until multiple mutations are present. If one mutation gives you an advantage, Darwinian evolution actually works pretty well. But when multiple mutations have to be present all at once before you get any advantage, this is where Darwinian evolution tends to get stuck. And it takes a long time to just get multiple mutations at once in a single organism when you have to have specific mutations before some advantageous trait will arise. So what all this is saying is that there's too much CSI in many proteins and enzymes in biology to be generated by Darwinian processes on any kind of a reasonable evolutionary timescale. But where in our experience does high CSI come from? Well, in our experience, high CSI comes from intelligent design. So because X exhibits, this is again the conclusion of the scientific method, because X exhibits high levels of CSI, a quality known to be produced only by intelligent design, we conclude that X was intelligently designed. And of course, we hold this conclusion tentatively, subject to future discoveries and future investigations. Like any scientific conclusion, we hold it tentatively, subject to future discoveries. Okay, so quick review. How does ID use the scientific method? First, we observe that intelligence is the cause of high CSI. Then we predict or make a hypothesis that life will contain high levels of complex and specified information. Then experimental research uncovers astronomical CSI in biological systems, so we conclude that life, or at least many aspects of life, were designed. So I think this is important to understand that ID uses the scientific method to make its claims. And this is a positive argument based upon our knowledge, our experience-based knowledge, that intelligence is the primary cause of high levels of CSI, and then we can apply the principle of uniformitarianism to explain where that CSI came from in the past, in the deep past. So our present day observation that intelligence is the cause of high CSI, that is the key to the past, the origin of the CSI in the deep past. And so we're using entirely accepted methodologies of historical sciences to make our case for intelligent design. Okay, so we got through the first bit here. Now we're going to talk about 5 testable predictions of intelligent design. We're going to look at 5 different fields: physics and cosmology, biochemistry, systematics, paleontology, and then genetics. So we'll try to get through these relatively quick. We started a little bit late, so I think I got about half hour left. Is that fair? Okay, all right, cool. All right, so, and by the way, as we go through this, we're going to make a positive case for design. I want you guys to focus on how we are going to be looking at a positive argument for design that's not merely based upon negating Darwinian evolution. Okay, so for our first testable prediction comes from ID in physics and cosmology. And we're going to start off with an observation. What are observations we can make of intelligent agents that will help us to make a prediction within physics and cosmology? Well, this is from a Cambridge University Press article by Stephen Meyer. He wrote, "Agents can arrange matter with distant goals in mind. They routinely find highly isolated and improbable sequences amid vast spaces of combinatorial possibilities." So what he's saying is that when you have a huge ocean of different possibilities, intelligent agents, they can sort of think with an end goal in mind, and they can find highly improbable solutions very quickly to solve complex problems. So I think this leads us to make a prediction within cosmology that the physical laws and constants of the universe will have improbable values that are finely tuned to allow for complex life. What we're really talking about here is high CSI. We'll get into that in just a minute. So what do I mean by fine-tuning? Well, cosmological fine-tuning, this is a definition by my friend and colleague at Discovery Institute, Bruce Gordon, who's a philosopher of physics, so a lot of fun at dinner parties. Cosmological fine-tuning refers to the unlikely forms taken by laws of nature which, logically and mathematically speaking, could have been expressed by an endless variety of different equations, and the unlikely values taken by constants of nature that do not emerge from physical theory, but are rather determined by measurement, which could only have varied in the minutest of ways from the forms or values if our universe is to be compatible with the existence of life. Okay, that's a big mouthful there. Let me translate it both for me and for you. So what he's saying is that basically fine-tuning is found when nature exhibits some unlikely property that matches a value or state that is a necessary requirement for the existence of life. So you see we're talking about something that is unlikely and matches a very specific pattern. So this is high CSI. We're basically looking for CSI in the laws and constants of physical laws and constants of the universe. So it turns out that it's well known in physics, this is actually pretty well accepted, that the universe is finely tuned for life. What I'm saying right now is not controversial among physicists. Not all of them necessarily would conclude intelligent design, although some of them would. And some folks who you might be surprised will conclude intelligent design based upon this evidence. But the very fact that the universe is finely tuned, that is pretty much, I think, beyond dispute. Of course, you can get into multiverses, but the fine-tuning is there. So what are some of the finely tuned parameters? Well, a few of them would be, for example, the strength of the weak or the strong nuclear force, the speed of light, the expansion rate of the universe, the electromagnetic constant, the gravitational constant. Why do I use this particular diagram to illustrate this? Well, pretend that you had a universe-creating machine, and every Saturday morning you could go downstairs into your basement, turn it on, and you could create universes. Well, it turns out that if you want to have a universe that's friendly to life, you have to have the settings or dials on this machine set to very precise values, or you will not get a universe that's friendly for life. So again, just a few of the finely tuned characteristics. I think I've mentioned some of these already, but you've got gravitational constant, which basically determines the strength of gravity, the electromagnetic force, the speed of light, the mass of neutrons, the mass-energy relation. These are sort of very large-scale parameters that are finely tuned. There's also more local parameters that are finely tuned, such as the spatial architecture of our galaxy, the type of galaxy we have, the type of star near planet Earth, the location of Earth within the galaxy, the properties of other planets in our solar system, the properties of water on planet Earth. If we didn't have Jupiter, then we would have far more comets in our solar system. Jupiter kind of acts like a cosmic vacuum cleaner. Its high gravity sweeps up a lot of these comets and meteorites that could otherwise be impacting Earth far more often, wreaking havoc on life. Water has many finely tuned parameters. One of the most famous ones is the fact that water floats as a solid. Usually the solid form of an element or a compound is more dense than the liquid form, but water is a rare exception to that rule, and as a result, ice floats. Why does this matter for life on Earth? Well, if ice didn't float, then the ice caps would sink to the bottoms of the ocean and basically freeze the oceans from the bottom up. And I think that would make either complex life very difficult, or it's hard to imagine how life on Earth could exist if all water was frozen. So one of the most amazing finely tuned parameters is the initial entropy of the universe. It's finely tuned. This comes from Roger Penrose, who's a very well-known, well-respected physicist. He found that the initial entropy of the universe is finely tuned to within 1 part in 10 raised to the exponent of 10 to the 123rd power. You can't even write out this number. We don't even have words to describe numbers this big, or I guess this small, I should say. And this is an incredible amount of fine-tuning. And again, I think that the fine-tuning of the universe is just really quite astounding once you start to study it. And also there's the evidence for a beginning of the universe. The stereotype sometimes is that Darwin skeptics don't like the Big Bang cosmology. I don't like that stereotype because, frankly, I think that the Big Bang model of the universe is a very compelling argument for design. You're basically finding that the universe exploded from an infinitely small point before there was space and time, and all the mass and energy in the universe was compressed down into an infinitely small point, and then it exploded out, and we have the universe. Well, in some ways, many physicists have actually said this points to a creation event. This is not coming from me. This is coming from physicists who see that as a compelling argument for design of the universe. So one of those physicists would be Charles Townes, who's a Nobel laureate. He says that intelligent design, as one sees it from a scientific point of view, seems to be quite real. This is a very special universe. It's remarkable that it came out just this way. If the laws of physics weren't just the way they are, we couldn't be here at all. The sun couldn't be there, the laws of gravity, the nuclear laws, magnetic theory, quantum mechanics, and so on have to be just the way they are for us to be here. He goes on to say, some scientists argue, well, there's an enormous number of universes, and each one is a little different, and this one just happened to turn out right. Well, that's a postulate, and it's a pretty fantastic postulate. It assumes that there really are an enormous number of universes, and the laws could be different for each of them. The other possibility is that ours was planned, and that's why it has come out so specially. And I think this is an interesting debate over the multiverse. Obviously, scientific conclusions need to be based upon what we can observe. We can only observe the universe we're in. We don't have any evidence for these other universes. And the funny thing is, actually, when you get into complex math, stuff that, okay, it's beyond me, but somebody like Bruce Gordon, a philosopher of physics, can explain this. When you get into the complex math, it turns out that the mechanisms that are invoked to generate the multiverse themselves require fine-tuning. So you actually can't get away from the fine-tuning problem even when you invoke the multiverse. It's a real problem for, I would say, materialists who want to believe that we just live in a lucky universe where there was no fine-tuning or special planning that went into our universe. Fred Hoyle, who was an atheist cosmologist, he famously said, a common sense interpretation of the data suggests that a super intellect has monkeyed with physics as well as with chemistry and biology. So I would say we find that the universe is finely tuned for life. There is high CSI. At the level of the physical laws and constants of the universe, we can infer design in the fine-tuning of the universe. So we start with the observation. Intelligent agents can find highly isolated and improbable solutions to complex problems. We make a prediction that the physical laws and constants of the universe will be finely tuned to allow for complex life. Sorry, I know this purple text didn't come out so good, did it? It's probably hard to read. I'll change that next time around. I thought purple was better than pink, but probably was wrong about that. The experiment, cosmological studies reveal astronomically unlikely fine-tuning for life. In the conclusion, the cosmic architecture of the universe was designed. So there you go, or universe. Okay, so testable prediction number 2. You couldn't see that because it was too dark. That's why I make my text dark, so you can't see my typos. So testable prediction 2, ID and biochemistry. So another observation about how intelligent agents work. Again, we're starting, the present is the key to the past. We're starting with present-day observations. Again, we're going to go back to this quote from Steve Meyer. He said, our experience-based knowledge of information flow confirms that systems with large amounts of specified complexity, especially codes and languages, invariably originate from an intelligent source, from a mind or a personal agent. All right, so another great quote, I think, that's along these same lines. In all irreducibly complex systems in which the cause of the system is known, by experience or observation, intelligent design or engineering played a role in the origin of the system. So there you go. These are 2 observations about what intelligent agents produce when we observe them in the world around us. So what's our testable prediction? Highly specified and irreducibly complex machine-like structures will be found in biology. So I'm going to talk about 3 levels of design in biology for you guys real quick here, where I believe that we find that this prediction is confirmed. The first is encoded information along our DNA. For the bio majors in the room, this is going to be old news, but let me just do it anyway. The backbone of your DNA molecule contains information stored in the form of these nucleotide bases. They're adenine, cytosine, thymine, guanine, represented here through the A, T, C's, and G's. And as we talked about earlier, mutational sensitivity tests and experiments have shown that the nucleotide sequence has to be very precise in order to yield a protein that performs a function. So we know that the ordering of these nucleotides in your DNA has to be just right, or finely tuned, you might even say, in order to yield functional biological structures. This is high levels of complex and specified information in your DNA. And what's interesting is that there is no physical or chemical law that dictates the ordering of the nucleotide bases in your DNA. Let me say it again. There is no physical or chemical law that dictates the ordering of the nucleotide bases in your DNA. Darwinian theorists would say that various types of mutations are what created the ordering of the information in the DNA. What ID proponents would say is, well, in our experience, when we find this kind of high CSI, it can't be generated by unguided processes like mutation and selection, and a better explanation is intelligent design. So if you just have the information in your DNA, that high CSI information, that alone is not enough to produce the proteins that make up your body and all living organisms. You need something else. So if you were to just have, say, a strand of DNA, and that's all you had, that would be like just having a DVD. A DVD by itself is essentially useless unless you have some way to read the information on the DVD. So the information in your DNA is useless unless you have some way to read and process that information. So that's why you need a DVD player, to read the information and process that information and give you some kind of a useful output. Well, what if the information for building the very first DVD player was encoded on a DVD? That would be a real problem, wouldn't it? You could never get that information off if you didn't have a DVD player. All you had was a DVD, and that DVD contained the information for building that DVD player. Well, in the same way, all of the molecular machines in your cells, which read and process the information in your DNA, are encoded by the DNA themselves. In order to get the information off the DNA, all those parts have to be present. The whole system has to be present. The DNA and all the information it requires to read the information off your DNA and build those molecular machines, all of those have to be present in order for the system to work. You have to have both the information and the machinery just to get the machinery in the first place. So this is kind of like a chicken egg worst nightmare problem, but this is the reality of the way living organisms work. And it turns out that the information in your DNA is, don't worry, this is not a real blue screen of death. I'm from Seattle, and I don't know Bill Gates. I'm sure he's a nice guy. I don't think he's pro-ID, and I do use a PC. So all you Mac people can rag on me for having a PC. That I do get lots of blue screens of death, by the way. What's interesting is that the information in your DNA is actually functioning much like computer code. It literally contains commands and codes which instruct your cells which amino acids to string in which order, when to start creating a protein, when to stop, how much of it to produce, where to put the protein. the timing of all kinds of cellular processes is regulated by the commands and codes that are embedded in your DNA. And for this reason, even Bill Gates has said, and again, I don't think Bill is pro-ID, but he says DNA is like a computer program, but far, far more advanced than any we've ever created. This is not a coincidence that he says this, because literally, your DNA contains information, and your cells use a computer-like system of information processing to read those commands and interpret them and generate some kind of a useful output and follow those instructions. And just like in computer programming, if you get a mutation in the DNA that screws up the commands, you might crash. That cell might die. That protein won't function properly. You might get cancer, a cell that's replicating out of control. An organism won't develop. So for those computer programmers in the room, you know that if you type the wrong command or even just misspell a word and then your program won't compile, that your programming is very sensitive to having the right commands and the right code in the right order. Same thing goes for the DNA. In many cases, it is insensitive to changes, which shows that you have these very computer-like commands and codes that are necessary to generate the complex features we see in life. Even Dawkins has said, the machine code of the gene is uncannily computer-like. Apart from differences in jargon, the pages of a molecular biology journal might be interchanged with those of a computer engineering journal. Isn't that interesting that even Dawkins is recognizing these similarities? And of course, what is the result of this information processing? Well, we're actually producing machines. So the result of the transcription and translation that's going on in living organisms, and then those commands are interpreted and read, they're putting together micromolecular machines. Your cells are full of molecular machines, hopefully not many of these, because this is the bacterial flagellum, and it only, well not only, it grows on many bacteria, but one of them is E. coli, which you do have in your gut, but if you have this being expressed, you might be getting sick. So E. coli, or the bacterial flagellum, is a very well-known molecular machine that has sort of become the poster child of the ID movement. Why is that? Well, because it's a molecular machine that we've studied quite a bit. We know a lot about the bacterial flagellum. We know how it works, and we know that it has many parts which we would recognize from human-designed machines. The flagellum has a rotor, it has a stator, it has a bearing, it has a U-joint or a hook, it has a propeller. It's even been discovered the flagellum has a brake and a clutch. So these molecular machines also are irreducibly complex. Here's a few of the engine specs on the flagellum. It's self-assembled and repair, water-cooled rotary engine. It's driven by proton motor force, although the exact mechanism is unknown. It has 2 gears, forward and reverse, and can change directions in a quarter of a turn. It operates around 18,000 RPM, although it's been clocked up to 100,000 RPM, and about 50 genes produce over 30 structural parts. So, and its energetic efficiency has been predicted to potentially be as high as 100%. So I would say that Ford Motor Company should take notes on this. This dwarfs the energetic efficiency and the complexity of really any machine that's been designed by humans. And this is from David DeRosier, who is not an ID proponent, he's actually an ID critic, but he has said that more so than other motors, the flagellum resembles a machine designed by a human. Isn't that interesting? So, and again, it is irreducibly complex, which means it is high CSI. Mutational genetic knockout experiments have shown that it has about 35 genes that form an irreducible core, which must be present in order for the E. coli flagellum to function. So this is a good example of irreducible complexity. There's a lot of other molecular machines out there. Your cells are literally full of them. But the point here is, what are we finding? It's at the very basis of biology. Okay, we're finding that the very base of biology is a language-based code in your DNA that is interpreted through a system of computer-like commands and codes and information processing to produce machines. Well, where in our experience does language-based code, computer-like information processing, and machines, where do those things come from? In our experience, they have only one known cause. That means at the very foundation of life, the things that are the very foundation of life, a language-based code, information processing, and machines, in our experience, those things come only from intelligent design. So I would say that we find a very compelling case for intelligent design in biology. So again, how does ID use the scientific method here in biology? Well, intelligent agents think ahead with an end goal to create a complex blueprint. Prediction is that highly specified and irreducibly complex machine-like structures will be found in biology. We can then do experiments, mutational sensitivity tests, theoretical simulations, knockout experiments, mutagenesis, etc. They find high CSI and irreducible complexity in nature. So we conclude that those systems were designed. So let's now look at systematics. First of all, what is systematics? How many of you guys have heard of the term systematics before? Okay, a couple people. Systematics is basically how we classify and categorize organisms. Today, the field is dominated by evolutionary thinking, where basically you want to classify and categorize organisms according to their evolutionary relationships. So is this a field that ID can contribute to? I think it is. I think ID actually has something to say within systematics, and we're actually finding that many of the discoveries in systematics of the last, I would say 10 or 20 years are challenging conventional evolutionary views, and I think they fit better under an ID paradigm. So here's a quote from two ID proponents that I think is relevant to making an observation about intelligent agents when we're studying systematics. They said, an intelligent cause may reuse or redeploy the same module in different systems without there necessarily being any material or physical connection between those systems. Even more simply, intelligent causes can generate identical patterns independently. We do so, for instance, every time we sign a bank check or credit card slip. Okay, so what are they saying? They're saying that intelligent agents tend to reuse different parts and different designs. And I think this can lead us to make a prediction. Boy, this red is hard to read, isn't it? I'm so sorry. If we could, I don't know if it's possible to shade the lights down just a tad, but it might help just a little bit. So I'm going to make a prediction here that complex parts will be reused in different organisms, but not in a manner that necessarily matches a nested hierarchy. So we'll talk about what that means and why that's important in just a minute. So complex parts will be reused in different organisms. So what's a phylogenetic tree? A phylogenetic tree, also known as a phylogeny, is a diagram or a hypothesis that purports to show the relationships between a group of organisms. And it's supposed to fit, according to a standard evolutionary view, a nested hierarchy. So you're supposed to have sort of a nested hierarchy where true groups will nest within another group and those groups will nest within another. And this is sort of the prediction of Darwin's concept of descent with modification. So there are two problems with phylogenetic trees. First, they're based entirely upon assumptions which ignore other possible explanations, and two, those assumptions often fail. So what are some of the assumptions that are built into phylogenetic trees? So when you guys see these tree diagrams in textbooks or in newspapers, you guys need to understand, these are based entirely upon assumptions. It's strictly assumptions that go into these trees. The trees are only as good as the assumptions that they make. So what are those assumptions? Well, the first assumption is simply that common descent is true. They assume that common descent is true from the very beginning. But that's actually not the assumption I'm most interested in. The assumption I'm more interested in is this, that functional biological similarity implies common ancestry or results from common ancestry. This is the main assumption that goes into all phylogenetic trees, that functional similarity in biology results from common ancestry. Let's talk this through. Let's cash this out a little bit. What does this mean? But again, remember, it's just an assumption. So how many of you guys have seen a diagram like this in your textbooks that show the various vertebrate limb structures, right? Okay, sure, we've all seen this diagram. Well, according to evolutionary biology, the reason why we have a similar limb structure in our bone structure in our limbs is because we share a common ancestor or various common ancestors with these different types of vertebrates. Bats, seals, sheep, humans, dogs, dolphins, pterodactyls, they all share similar bone structures in their limbs. Not identical, but there's a similar pattern. And according to evolutionary biology, this is because they shared common ancestors that had this same limb pattern. So I would say yes, common descent is one possible explanation for this. But is there another possible explanation? Well, I would say there is. I would say common design is another possible explanation for why organisms have functional biological similarities. These organisms may have been designed based upon a common blueprint because this is very useful design upon which to build a limb with the kind of bones that we find in vertebrates. So common design might be another way of explaining these similarities rather than common descent. Again, I'm not saying if you think that common descent explains this, I'm not saying you're crazy. I'm just saying let's be realistic. There's another option here that really evolutionary biologists don't even think about most of the time. They're thinking inside of a box, and they don't even think about the possibility that common design might be the explanation. They don't recognize the fact that designers will regularly reuse parts that work in different designs, right? We see that wheels are reused on cars and airplanes. We see that keyboards are reused on cell phones and computers. So designers will regularly reuse parts that work. So another example is that human and ape DNA is 99% similar. Is that an argument for common descent? No, because, well, for one, their similarity is actually less than 99%. Some estimates would say it's as low as 70%. But even if it was 99%, I don't care what percent you put on it, why must functional genetic similarity require common descent? Why isn't it possible that a designer reused parts that work, in this case, genetic components, in different designs and built humans and apes upon a common blueprint? That's an equally good explanation, in my opinion, for functional genetic similarity in living organisms. So, for example, in computer programming, designers will regularly reuse computer programs that perform the same function. A good example. So design upon a common blueprint is a perfectly good explanation for why humans and apes share similar DNA. So again, designers regularly reuse functional components in different designs. The same quote that we just saw. And what am I talking about here? Well, computer programmers will regularly reuse computer programming modules in different designs. You can see that just from the intro screens to these various versions of Windows, right? They're using similar programs to boot computers. And why? Because you don't necessarily have to always reinvent the wheel. You can reuse programs that work in different designs. Sometimes we wish they would reinvent the wheel with Windows, and actually they have, which is why Windows 7 is a lot better than Windows Millennium. Do you guys remember that? Oh gosh, that was a nightmare days. Okay, I see some heads nodding, yeah. But the reality is that programmers do reuse the same module over and over again in different designs. So another example would be two eyes. The fact that Mr. Bean and Lady Gaga has two eyes. They each have two eyes. What does that mean? I don't know. What on earth does this mean? So shared functional biological similarity. Is that the result of common ancestry? I would say, as hard as it is to believe, yes, Mr. Bean and Lady Gaga do share a common ancestor. Or maybe it's not so hard to believe, actually. So this is a good example where functional biological similarity probably is best explained by common ancestry. Okay, what about this one? Two eyes. Does this imply common ancestry? Well, maybe, maybe not. I think that it could. I think that one explanation for why humans and dogs both have two eyes could be because they shared a common ancestor. But it also could be explained by common design. So it's kind of a push here, but it's possible. It's definitely possible. What about this one? What is this, by the way? Anybody know? Oh, you see it up there. Okay. So humans and octopus. That's an octopus. So does the fact that humans have two eyes and octopi have two eyes, is that the result of common ancestry? Who says yes? Very good. Even evolutionary biologists would not say that this is the result of common ancestry. They would say it's the result of convergent evolution. We don't even know if the common ancestor of humans and mollusks had an eye or had any kind of an eye. So this is certainly not the result of common ancestry. This is a great example of where functional biological similarity does not necessarily mean inheritance from a common ancestor. So that assumption that all phylogenetic trees is based upon, it just failed right here. You're looking at a failure of the assumption that goes into every phylogenetic tree you've ever seen. This is a counterexample of that assumption. That assumption fails all the time. You might think, okay, well, maybe it's useful to have two eyes. All right, maybe just by chance they both came out with two eyes. It's not so hard to believe convergent evolution. Well, look at this. Humans and octopi actually have an almost identical design structure to their eyes, and we don't even know if their common ancestor had an eye. Is convergent evolution a compelling explanation for this? Well, again, their eyes are not identical, but there's a heck of a lot of similarities there. Is shared functional similarity really necessarily imply common ancestry? No, it does not. Though human and octopus eyes have very similar designs, Darwinians would just chalk this up to convergent evolution. The fact that a nearly identical eye design was used in widely disparate organisms, and we cannot explain this through common ancestry, we cannot explain these highly similar eye designs through common ancestry. This is not the result of common design. This is the result of convergent evolution. And they use this explanation over and over and over again in biology because there's so many examples of convergent evolution. Bat and whale, echolocation, convergent evolution. The examples are almost without end of convergent evolution, so-called, in biology. But I would say common design is a much better and compelling explanation for these shared functional biological similarities. What about this one? Humans and a fly. No, again, convergent evolution. The fact that humans and flies have two eyes is strictly a coincidence. After all, other arthropods, like a spider, they have what? Is it 6 eyes or 8 eyes? So the fact that humans and flies, fruit flies, have two eyes is strictly coincidence. Darwinians would call this, again, convergent evolution. But the similarities, again, go much deeper because it turns out that even though we have no idea whether the common ancestor of humans and arthropods even had an eye, the same genes are used to regulate and control eye development in both of these organisms. So even though we don't even know if the common ancestor of humans and arthropods had an eye, this gene here, PAX6, controls eye development in both flies and humans. We would call this convergent genetic evolution. And I would say that when you're getting down to this level of similarity, again, common design is a much better explanation. So, assumptions break down. The main assumption that underlies phylogenetic trees is really more like this. Functional similarity implies common ancestry, except for when it doesn't. Because we see so many exceptions to this rule that they really threaten to, how do you know when the rule is true? I'm not saying the rule is never true. I'm just saying, how do you know the rule is true? So it turns out that this problem leads to conflicts between various phylogenetic trees. The problem is that when we look at the data from biological systems, we cannot construct a consistent phylogenetic tree of life. So within the basic domains of life, you can't construct a nice, neat, nested hierarchy like this. You get a web of life. You get this tangled thicket. You don't get a nice, neat Darwinian tree that's able to describe the relationships of the basic domains of life. So genes are appearing in a pattern that cannot be explained by common descent. And there are many examples where biological similarities appear in places that cannot be explained by common descent. Now, some folks would say that the problem with the tree of life in the basic domains can be explained by horizontal gene transfer, where organisms acquire some of their genes from a neighbor rather than through vertical inheritance from a parent. And I would say that that is not a helpful explanation. For one, many of the tangled, I know I'm getting a little bit technical here, but hopefully some of you guys are still with me. Many of the tangled pathways at the base of the tree of life result from genes that encode fundamental molecular machinery. And while horizontal gene transfer can occur within some bacterial or unicellular genes, it's hard to explain how it could occur within all these essential genes. And also, conflicts within the tree of life are also prevalent within more complex organisms, such as plants or animals, where such gene swapping is not readily observed. We have to always infer. We don't actually directly observe it. So there's difficult to just explain away this bad data through horizontal gene transfer. I would also say that we have to ask, is it even possible to falsify common descent? Phylogenetic conflict, like we saw in that tangled thicket, is no longer taken as evidence of problems with common descent. Rather, it's taken as evidence for horizontal gene transfer. Here's a nice quote from a paper. In the phylogenetic approach, each instance of topological discordance between a gene tree and a trusted reference tree is taken as prima facie instance of lateral gene transfer, which is the same as horizontal gene transfer. What am I saying here? Well, they're not actually looking at testing common descent. They're not making common descent a falsifiable hypothesis. Whenever there's data that conflicts with your tree, they use that as a way of inferring this sort of escape hatch explanation of horizontal gene transfer. This is kind of like a few hundred years ago when people still believed in the geocentric model of the solar system, that all the planets and the sun went around the Earth. And sometimes they would observe data that did not fit with that model. Sometimes a planet would actually go backwards for a little while. We know now that that's because the Earth is not the center of the solar system. The sun is, and it makes perfect sense why, based from our vantage, sometimes planets would switch directions. But when people still believed in the geocentric model, they would find evidence that contradicted their model, and they would explain it away as being the result of an epicycle. Well, what's an epicycle? It's when a planet goes backwards. And why does that fit our model? Well, because sometimes planets just go backwards. But don't worry, the model isn't wrong. The planets just go backwards sometimes. What we're finding is that common descent is starting to go that direction, where there are so many secondary explanations, epicycles, to explain away data that does not fit a tree-like pattern, that you have to wonder whether the tree-like pattern really ought to be taken seriously anymore in the first place. This is a paper from the journal New Scientist. A couple years ago, was titled "Darwin Was Wrong About the Tree of Life." And actually some biologists are now rejecting the idea that there was a tree. They say many biologists now argue that the tree concept is obsolete and needs to be discarded. We have no evidence at all that the tree of life is a reality. The problem was that different genes told contradictory evolutionary stories. We've just annihilated the tree of life. It's not a tree anymore. It's a different topology entirely. So I can give you quote after quote from this. I'll just give you guys a few. Phylogenetic incongruities or conflicts can be seen everywhere in the universal tree, from its root to the major branchings within and among the various taxa to the makeup of the primary groupings themselves. We're talking about a non-tree-like pattern, conflicts in the tree of life. Here's another one. I'm trying to explain the evolutionary relationships of the basic animal phyla. Despite the amount of data and breadth of taxa analyzed, relationships among most metazoan phyla remain unresolved. A major challenge for incorporating such large amounts of data into inference of species trees is the conflicting genealogical histories often exist in different genes throughout the genome. The problem is that one gene gives you one version of the tree of life, and another gene gives you an entirely different and conflicting version of the tree of life. The genetic data is not painting a consistent picture of common descent. Here's a quote from a paper from last year. Incongruence between phylogenies derived from morphological versus molecular analyses and from between trees based on different subsets of molecular sequences has become pervasive as data sets have expanded rapidly in both characters and species. This paper said phylogenetic conflict is common and frequently the norm rather than the exception. What they're saying is that it's normal now to have difficulty constructing a nice, neat Darwinian tree. It's the exception when you can get a nice, neat Darwinian tree. Isn't that interesting? Isn't that interesting? What about when you compare trees based upon molecules like DNA sequences with trees based upon anatomical characteristics of the morphology? This is a review article from Nature a few years ago. It said, evolutionary trees constructed by studying biological molecules often don't resemble those drawn up from morphology. No matter how the computer analysis was run, the molecular and morphological trees could not be made to match. This is what she's talking about, just resolving the relationships of higher primates could not be done. Molecular data gave you one tree, morphological gave you another, and this is the kind of thing I'm talking about, and it's all over the place in systematics today. So what's going on? The basic problem is that complex biological similarities appear in places not predicted by common descent, contradicting a nested hierarchy. But if designers will regularly reuse functional parts, programs, and components of different designs, might common design be a better explanation than the failing geocentric model of common descent? What's going on? We have reuse of different parts in different organisms. That's what's going on. It's exactly what design would predict. ID predicts that parts will be reused in different organisms, but not in a manner that necessarily matches a nested hierarchy. Observation. Intelligent agents, this is again, ID and systematics using the scientific method. We observe that intelligent agents reuse functional, useful components and blueprints over and over in different systems. We predict that complex parts will be reused, but not in a manner that necessarily matches a nested hierarchy. Experiments will phylogenetic trees commonly conflict, shared biological similarity is prevalent, and complex features shared which cannot be explained by common descent or even maybe I would say convergent evolution. And conclusion, I think common design is prevalent throughout life. Okay, let's finish this up here. We just got a couple quick last modules to go through and then we'll open it up for questions. So we doing okay? All right, cool. So ID and paleontology, testable prediction number 4. Let's start off again with an observation of how intelligent agents work. Intelligent design provides a sufficient causal explanation for the origin of large amounts of information since we have considerable experience of intelligent agents generating informational configurations of matter. What am I saying? Intelligent agents are capable of rapidly infusing large amounts of information into a system like the biosphere. I think this leads us to predict that novel forms will appear abruptly in the fossil record without similar precursors. Well, what do we find? Well, it turns out that we find that the fossil record contains a pattern of explosions where biological diversity appears abruptly without similar precursors. This is a diagram from a paper in the journal Trends in Ecology of Evolution, and it's supposed to show the origin of the major animal phyla. And as you can see, the animal phyla appear abruptly in the Cambrian period about 500 million years ago in the Cambrian. So what this diagram shows is the thick black lines represent the periods of time for which we have known fossils representing a various phylum. The thin black lines represent the evolutionary history that's predicted by evolution for which we do not have fossils. And as you can see, nearly all the major animal phyla, these are not known to be animals, but so here you've got the animal phyla. Nearly all of them appear about the same time in a geological instant essentially, or geological blink of the eye, about 530 million years ago in the Cambrian period. Things as diverse as mollusks or annelid worms or arthropods or vertebrates. Now, Interestingly, the vast majority of the horizontal distance on this diagram, where you have different groups actually evolving to common ancestors, it's all thin black lines. So the evolutionary connections of these major animal phyla is not known from fossils. Instead, we see that they appear abruptly in the fossil record about 530 million years ago or so. Now, here you do see a thick black line that covers horizontal distance. So what does that mean? Well, actually, this diagram came from a paper in 1998, and the next year they actually found vertebrate fish in the Cambrian explosion. So if you were to redraw this diagram now, you would actually draw the vertebrate line all the way back to the beginning or somewhere in the Cambrian explosion. So this, I think, is very compelling argument that complex animal forms and biological organisms appear abruptly in the fossil record without similar evolutionary precursors. Here's a great quote from a paper in Bioessays discussing this. It says, as explained on an Intelligent Design t-shirt, fact, 40 phyla of complex animals suddenly appear in the fossil record, no forerunners, no transitional forms leading to them, a major mystery, a challenge, theory of evolution exploded again, idofcourse.com. They're quoting this. Although we would dispute the numbers, and aside from the last line, there's not much here we would disagree with. Indeed, many of Darwin's contemporaries shared these sentiments, and we assume if Victorian fashion dictated, they would have worn the same shirt with pride. These authors are not proponents of intelligent design. They go on to give you, I would say very weak, but at least they're trying to give you a materialistic account of the Cambrian explosion. But looking at the fossil record at face value, isn't that interesting? I think that's very interesting. That's what ID would, I think, very, very much consistent with the prediction of intelligent design. Here's a quote from an invertebrate biology textbook. It says, most of the animal phyla that are represented in the fossil record first appear fully formed in the Cambrian some 550 million years ago. The fossil record is therefore of no help with respect to the origin and early diversification of the various animal phyla. Here's a quote from a great book that just came out this year by two leading Cambrian paleobiologists. They admit in this quote that from their vantage as evolutionary biologists, the Cambrian explosion is unresolved. They say, the patterns of disparity observed during the Cambrian pose two unresolved questions. First, what evolutionary process produced the gaps between the morphologies of major clades? Second, why have the morphological boundaries of these body plans remained relatively stable over the past half-billion years? In other words, what produced all this diversity? It's unresolved. And why did new animal phyla appear since that time? They don't know the answer to that question either. I think this is very interesting. And of course, the Cambrian explosion is not the only explosion in the fossil record. There are other explosions. Here's a quote from another zoology textbook. It says, many species remain virtually unchanged for millions of years, then suddenly disappear to be replaced by a quite different but related form. Moreover, most major groups of animals appear abruptly in the fossil record, fully formed with no fossils yet discovered that form a transition from their parent group. Now, am I saying that there's no potential candidates for transitional forms out there? No, there are a few, and I don't have time to get into that right now, but you guys want to talk about it, some of those we certainly can. But the pattern, the overall general pattern we see in the fossil record is one of abrupt appearance. Isn't that interesting? So some other explosions we see would be the radiation of mammals, a big bloom of flowering plants where angiosperms appear explosively, the marine Mesozoic revolution, and of course the Cambrian explosion. So conclusion, ID and paleontology. Observation, intelligent agents can rapidly infuse large amounts of information into systems. Hypothesis, novel forms will appear abruptly in the fossil record. Experiment, fossil record shows a pattern of explosions where new types appear suddenly, e.g. the Cambrian explosion or the mammal explosion. Conclusion, many higher taxa arose by intelligent design. All right, last one here, you guys. This is real short. ID and genetics. What is a prediction ID can make? Well, since non-coding regions do not produce proteins, Darwinian biologists have been dismissing them for decades as random evolutionary noise or junk DNA. From an ID perspective, however, it is extremely unlikely that an organism would expend its resources on preserving and transmitting so much junk. So I think ID gives us a testable prediction regarding junk DNA. I would say that ID predicts the cell will contain less functionless junk and biology will tend not to contain functionless parts. So here's a quote from the journal Science. They actually said that the concept of junk DNA, which was born and bred from an evolutionary paradigm, that it basically discouraged researchers from studying the function of this non-coding DNA. It says the term junk DNA for many years repelled mainstream researchers from studying non-coding DNA. Who, except a small number of genomic clochards, would like to dig through genomic garbage? However, in science, as in normal life, there are some clottards who, at the risk of being ridiculed, explore unpopular territories. Now, more and more, biologists regard repetitive elements, which is a type of non-coding or what they thought to be junk DNA, as genomic treasure. So isn't this interesting? So where are we at now? Well, a paper came out last year in the journal Nature from the ENCODE project, a consortium of over 400 scientists from around the world trying to determine if there is biochemical activity for non-coding DNA. And they found, this is from the abstract of a Nature paper last year, from over 400 leading scientists from around the world. They said, these data enable us to assign biochemical functions for 80% of the human genome, in particular outside of the well-studied protein coding reasons. So the evidence is pointing in the direction of finding function for non-coding DNA. And there are literally hundreds, if not thousands, of studies that have come out in the last 5 to 10 years that have confirmed this prediction of ID. Long before, by the way, ID firms were predicting we would find function for junk DNA long before these kinds of discoveries were being made. And so I think this is a very successfully confirmed prediction of ID. Well, they said only 80% of the genome looked like it had biochemical function. Well, it turns out that this project so far has only looked at about 147 cell types within humans. And given that we have a few thousand cell types, they predicted it's likely that the 80% will go to 100%. This is a quote from a pro-ID biologist, Richard Sternberg. He says in a peer-reviewed paper, the selfish junk DNA narrative and allied frameworks must join the other icons of neo-Darwinian evolutionary theory that, despite their variance with the empirical evidence, nevertheless persist in the literature. So, conclusion here for ID and genetics, I would say, again, observation. Intelligent agents generate functional information sequences, and they generate things that have a function. The hypothesis is that the cell and biological systems will tend to not contain functionless junk. Experiment, numerous functions are being discovered for non-coding DNA, especially regulatory functions. And the conclusion is that biological functionality is, I think, most consistent with intelligent design. So we're closing it up here. Just to sum up, what is the basis for intelligent design? Well, I would say you have the discovery of biochemical language and irreducibly complex molecular machines. You have the discovery of digital information and information processing systems in the cell. You have the discovering of the fine-tuning of the laws of physics and the constants of physics. And most importantly, our inference to design is based upon our knowledge of the cause and effect structure of the world. We know from experience that these sorts of things, high levels of complex and specified information, digital information, information processing in machines, and our experience, these things come only from intelligence. So based upon our knowledge of the cause and effect structure of the world, we can infer that an intelligence was at work. So you can disagree with my conclusions here, but I think it's tough to argue that the argument for design I've made is based upon religion, faith, or design revelation. You can disagree with the argument, you can disagree with the conclusions, but the argument itself is a scientific argument. So again, it's okay to disagree with ID. So if you're saying I disagree with ID, intelligent design, I have no problem with that at all. What I do have a problem with this is therefore it must leave the academy. And we see a lot of folks these days that are trying to censor intelligent design. The president of Ball State University about a month and a half ago actually implemented a speech code where she's now banned science classes at Ball State from talking about intelligent design. So I would say that this is totally legitimate, but this is dogmatic, and it's not constructive for scientific progress. So thank you guys very much, and I'll take questions as long as they let me stay. So thanks a lot.